Hello everyone. Welcome to the solution of LeetCode problem 47 named Permutation 2. In this problem, we are given a collection of number and we have to return all possible unique permutations. But there is a constraint. The constraint is the input can contain duplicate values. And fortunately, we can return the answer in any order we wish. Now, at first, let us understand the second example. Here, the input contains three elements, which is 1, 2, and 3. And all possible permutations of these three elements is 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So there are 6 permutations of this three value. Anyways, for the example 1, our input vector also contains three elements, which is 1, 1, and 2, but 1 appears 2 times. So there is a duplicacy. In this case, the unique all possible permutation is 1, 1, 2, 1, 2, 1, and 2, 1, 1. So here we are noticing that in the example 2, the array contains 3 elements and it has 6 permutations, as the input array does not contain any duplicate element. But when we have one duplicate element in our input array, the number of unique permutation reduced into 3. So we can say that if our input array contains unique element, then the number of all possible permutations can be reduced. Anyways, I hope you understood the problem. Now let's move on to the constraint. Here, the number length or the array length can be in between 1 to 8, and each of the array element can be in between -10 to +10. I hope you understood the constraint. Now let's move on to the intuitive approach of the solution. Before starting the solution, I want to tell you something. We have solved similar problem earlier named only permutations. The only difference between the previous problem and this problem is, in the previous problem, all elements are unique, but in this problem, there can be duplicate value in the input array. I hope you understood the difference between the previous and the current version of this problem. Now let's jump into the solution. At first, let's consider the first example, which is 1, 1, and 2. Now, if we ignore the value 1, our input can contains only the value 1 and 2. Again, for this 1 and 2, if we ignore the value 1, our input array contains only the value 2. Now, from these two, we cannot go any further because it is the base condition. So from here, we have to return to the caller node. And after that, as we ignore the value 1, we have to append the value 1 at the last of the vector. So now our vector is 2 and 1. Now from this 2, 1, we have to ignore 2. So our input vector can contain only the value 1. So from this 1, we cannot go any further because this is the base condition. So we have to return from this 1. And as we ignore the value 2, while exploring this path, we have to insert the value 2 at the last of the vector. So now our vector contains 1 and 2. So I am writing it down here. Now, as we have explored all of the left and right subtree of this node, so we have to return from this node as well to the root vector. So now, as we ignore the value 1, we have to append the value 1 at the last of the vector. So we are appending 1 here, and we also append 1 here and here as well. So far so good. We have found two permutations which contains three elements, which is 2, 1, 1 and 1, 2, 1. Now for the second subtree, we have to ignore the value of second one. Now, if we ignore the value of second one, our input array will become 1 and 2. But we have already explored the decision tree of this node 1 and 2, which is this 1 and 2. So we don't have to explain anything from this node. Now again, for the third subtree, we have to ignore the value of last two. So currently our input vector will contain 2, 1. Now for this 2, 1, we have to ignore the first one, and our input vector will contain only the value 1. And now we have to insert the value 1 into the set. So we are inserting value 1 here. Again, we don't have to explore anything from this 1 anymore because this is the base condition. Now we have to return to the caller node. Now we have to append the ignored 1 at the last of the vector. So now we have to ignore this one. So now we have to check either I can explore the only remaining one or not. But wait a minute. We have already one presented in our set, which is exactly similar to this one. So we cannot consider one in this path. This is strictly prohibited. So by comparing the value presented in the set, we can remove the duplicacy from this problem. So we can say that we cannot explore the second portion of this tree, which contains another one. So from this 1 and 1, we will get back to the caller node. So we have to insert 1 here and 1 here. And before exploring the path, we have ignored the value 2. So we have to insert the value 2 here. Now we have explored all of the permutation of this vector 1, 1 and 2. Now let's move on to the code. In this code, at first we are given a function permute unique, and the parameter of this function is a vector. The function will return a list of vectors, and at first we have to declare a list of vector with the name result, which will store the answer. Then we have to recursively call a backtracking function. The first parameter of this function is the input array. The second parameter of this function is the starting position of the backtracking algorithm. The third position of this function is the resulting array. Now, in the backtracking function, if our current start position is equal to the array size, then we have to append the current vector to the resultant vector. Otherwise, for each call, we have to take a set and we have to run a for loop from start to the array size. And each iteration, we have to check whether our current element is present in set or not. If our current element is present in set, that means we have found a duplicate value. So from this, we have to continue. Otherwise, if we do not found our current element into the set, we have to insert our current element into the set, and we have to swap the starting position and the ith position. After that, we have to recursively call the backtracking function from the next position, which is start plus 1. And after completing the backtracking function from the next position, we have to again swap the number. Because by using these two swap, we are returning to the original position of this vector. And at last, we have to return the result. I hope you understood the code. Now let's move on to the time and space complexity of this program. The time complexity of this program is big O of n factorial because here we have 3 positions, and in the first position we can insert any of the value. So here in the first position we have 3 choices. After placing one element in the first position, for the second position we have 2 choices, and after placing 2 elements in the first 2 positions, for the third position we have only 1 choice. So total choice is 3 times 2 times 1, which is 6. So we can say that in the worst case, the time complexity is big O of n factorial because 6 is equal to the 3 factorial, where 3 is the size of the vector. And we can say that the space complexity of this program is also big O of n factorial because in the worst case, the size of our resulting vector can be equal to the n factorial as well. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.